Welcome to day 6, transformations of sine and cosine graphs. We already did some graphing of sine and cosine on day 4. The only thing we did for transformations were the amplitude changes and the midline changes. And those were the letters A and D. Today's class is going to focus on what happens when there's a B and a C. So our basic function for our sine and cosine graph is has a period of 2 pi, midline is 0, amplitude of 1, and the range is -1 to 1. Today we're going to do all 4 transformations. Sometimes we have 2 things going on, sometimes we have all 4. So the A value will be the amplitude. The amplitude would be whatever the absolute value of A is, because amplitude has to be positive. And we should also make note of what type of graph it is. If it's a sine graph, it's at the midline and goes up. If it's a negative sine graph, it starts on the midline and goes down. If it's a cosine graph, it starts at the maximum and goes down. And if it's a negative cosine graph, it starts at the minimum and goes up. Okay, that's what I kind of get from A, if A is positive or if A is negative. The other thing that we did last class was D, and we said the midline was Y equals a D value, and it shifts the graph up or down. So we also talked about how first I draw the midline, and second thing I do, I use the amplitude to mark off the min and the max values on the graph. Now the other 2 things we're going to talk about are B and C. I'm going to do B first. B helps out with the period because it changes the x. It's a horizontal stretch or compression. And the period is a formula 2 pi over B, or 2 pi times the reciprocal of B. That is my formula for period. And what's going to happen, I'm always going to make whatever the period is, just like I did on yesterday, always be the 4th tick on the x-axis. Okay, that's what I'm always going to do. I'll do this third because this marks my x-axis for me. And the other thing I'm going to pay attention to is then the first tick is equal to 1/4 times the 4th tick, or 1/4 times 2 pi over B. And that's how I'm going to figure out how I could label my tick marks on the x-axis. And the last thing we have here is C, and we have something called phase shift. So C, as we know, moves things left and right, and because these graphs are special, they have phases, kind of like a moon has a phase. It repeats itself over and over and over again. The formula for phase shift is -C over B, and we talked about this before. It's not any different. Or I could call it -C times 1 over B if you want to use a reciprocal. And what is it going to do for me? It is going to move the first dot on the graph. So how we use this information before to figure out where my first dot goes? This phase shift, which I'm going to do last, it's going to plot that first point. That first point may no longer be on the midline. It may no longer be on the y-axis. It's going to be moved from the y-axis. Right now I'm putting all that first point on the y-axis. This is going to move the first point. So let's talk about an example. I'll erase all that. So I can tell right now I have the letters A, B, and C. And technically I have a D at +0. So my midline is y equals 0. I'll draw that across the page. I have my amplitude is my A value, which is equal to 4. So here and here are my max and my min values, and I know my range is from -4 to 4. I also know that this is a negative cosine graph, which means I start at the minimum and go up from there. So my first dot should be right here. I'm going to put it in gray, right here at the minimum. That's where my first dot should be. Negative cosine graph starts at the minimum and goes up from there. So I have, this is my d value, this is my a value. My period is going to be 2 pi over b, or for this example, 2 pi over 5. That means this is my fourth tick on the x-axis. 1, 2, 3, 4. This is 2 pi over 5. But I want to label all the x's, all the tick marks. So I'm going to take this result. I'm going to do the first tick is going to be 1/4 times 2 pi over 5. I get 2 pi over 20 or pi over 10. So this very first tick mark is equal to pi over 10. I'm just going to count squares. If you notice, I have these x values are like 1, 2, 3, 4, 5, 6, 7, 8. I could do it in reverse. Well, if you notice, this guy here is 1 pi over 10. The next one is going to be 2 pi over 10, 3 pi over 10, 4 pi over 10. I'm just going to keep on going and going as I count each square. Based on the first square is 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. But what I should do is reduce fractions when I can. So it's 1 pi over 10, 2 pi over 10 becomes pi over 5. 3 pi over 10 stays 3 pi over 10. I could do in reverse. Negative pi over 10, negative pi over 5, negative 3 pi over 10, negative 2 pi over 5. I could count more forward. You don't even have to. I want to see the first 4. After that, you don't have to do anymore. This becomes 5 pi over 10 becomes pi over 2, 3 pi over 5, 7 pi over 10. And the last one is going to be 4 pi over 5. So that's labeling the x-axis. I really only need to label the first 4 tick marks, but I label them all. On my phase shift, negative c over b, or in this case, positive pi over 5. The opposite of c over b, in this case, becomes positive pi over 5. If I look carefully, positive pi over 5 is right 2 squares. So this first dot that was here, I'm going to move right 2 squares. So I'm going to put in blue. My first dot is no longer on the y-axis, it's over here in blue. Still at the minimum, I have to go minimum, midline, maximum, midline, minimum, midline, maximum. I just follow my pattern over and over again, and I have all these blue dots. I could draw this graph. Make sure when you get to the max or the min, you're curving back, and this is the graph of negative 4 cosine parentheses 5x minus pi. Now if you look carefully, because it starts at the max, it could have been y equals positive 4 cosine of 5x without a phase shift. Okay? Because the 5x does the x-axis, the 4 now is positive because it's starting at the max, and with no phase shift, I don't need that minus pi at the end. So this next graph, I do have all full letters A, B, C, and D, and the midline here is at the end, y equals negative 2. I'm going to draw across the page. I notice I have amplitude of 3, so I'm going to go up 3 and down 3 and mark my min and maxes, and I can see right now that my range is from negative 5 to 1. This is a cosine graph, a positive cosine graph, so I'm going to start the max this time. So my first dot I'm going to put here in gray should be right here on the y-axis. My period is equal to 2 pi over b, which is going to be 2 pi over 3, which is my fourth tick mark. 1, 2, 3, 4. This is 2 pi over 3. I'm going to multiply that by 1/4 times 2 pi over 3, and I get pi over 6. If I label this, the first tick mark is going to be 1 pi over 6. The next tick mark is going to be 2 pi over 6, also known as pi over 3. The next square, the third one, is going to be 3 pi over 6, which is going to be pi over 2. And I could put them in reverse, but I don't have to. And now my phase shift, which I'm going to actually make this bigger. My phase shift is negative c over 2b, or negative c times 1 over b. So I would do negative pi over 2 divided by 3. I don't really like that much. I'm going to multiply by 1/3. I'm going to get negative pi over 6. Pi over 6 is 1 square, so negative pi over 6 is left 1 square. So this first dot is going to move right here. It is left 1 square. Well, I have no choice. If it goes from max, the next one has to be at the midline, minimum, midline, max, mid, min, mid, max, mid, mid, min, and back at the midline. I'm going to draw this graph, and I get this looking graph like this. And that is a graph of g of x. If you pay really close attention to this, because the first dot was at the midline going down, this is a negative sine graph. So it could be y equals negative 3 sine of 3x. I don't need the phase shift any longer, minus 2. Okay? That would be another way to write that equation. Because since these graphs repeat over and over and over again, I could use either sine or cosine to write the equation of every single graph. Okay, the next problem, I see I have this 3 cosine 2x plus pi plus 2. The midline is at the end is 2. The amplitude is the initial number is just 3. I'm going to go 3 up, 3 down. I can see my range is always negative 1 to 5. That's obvious. My period is 2 pi over b, so 2 pi over 2. My period is pi. That's my fourth tick mark. 1, 2, 3, 4. That's pi. I'm going to multiply that by 1/4. I get pi over 4 is my first tick mark. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, so on and so forth. If you want, you can do some in reverse. Negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. If you want to do some in reverse. My phase shift is negative c over b. So in this case, it would be negative pi over 2. And you can see that negative pi over 2 is left 2 squares. Since this is a cosine graph, my first dot should have been here at the max. But now I'm going to move it over left 2 squares. So the first dot was moved. And after that, since I'm at the max, it's going to be, I'm sorry, that's not the max. I made a mistake. That's the midline. Let me go back. Here's my red midline. My max is right here at 5. I got to go left 2 squares. I'll put that first out as blue. So right here at the max, at x equals negative pi over 2 is the max. Middle, min, middle, max, middle, min, middle, max, middle, min, so on and so forth. And I could draw this graph. Remember, if you have these at the end here, please do not draw them going down. They curve back up. And there you go. And if you notice, this graph starts at a minimum on the y-axis, so you could rewrite it as a negative cosine graph if you wanted to, but I'm not going to on this example. I already did it twice. Okay, the next example, I have the letters A, B, C, and D, and I can go to it. And that won't erase. Okay, my D value is -1. I did the midline at -1. My amplitude is 4. I'm going to go up 4 to here, down 4 down to here. It's a sine graph that starts at the midline, so the first step should be right here on the midline. And go up from there. Since I already have my min and max value, I know it's going to be from -5 to 3. My period is equal to 2 pi over b, or 2 pi over pi, which is just equal to 2. So on the fourth tick mark, 1, 2, 3, 4, I have the number 2. I'm going to multiply that by a fourth. So a fourth times 2 is equal to 1/2. And that is the first tick mark. So it goes 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2, so on and so forth. You want to do it in reverse. You could do it in the reverse. And that's the x-axis from -2 to 2. My phase shift is normally -c over b, except I don't like this pi, so I'm going to do -c over 1 times 1 over b. And it's going to be -pi over 2 times 1 over pi, because that's the reciprocal of b. I notice I get -1/2. And -1/2 is going to be left 1 square. So this dot here is going to move left 1 square. So the first dot normally is on the y-axis, has been moved left, and it's right there at -1/2. And since it's a sine graph, it's going to go all from there. It's going to go from midline to max, midline to min, midline to max, midline to min, and so on and so forth. And I get this graph. And there we go. There's that graph. And since it starts at the max on the y-axis, I could rewrite it as a cosine of x graph. Next example, I have more going on here. I see my A, B, C, D value. So this is D, Y equal 1 is my midline. I have my A value of amplitude of 2. So I go up 2 and down 2. So -1 to 3 is my range. This is a negative sine graph. So I'm going to start on the midline as my first dot and go down from there. That's what's going to happen for this graph. And I'll do my other features. I'm going to do 2 pi times 1 over b, because of this half being b. So it'll be 2 pi times the reciprocal half is 2. So my period is equal to 4 pi. 1, 2, 3, 4th tick mark is 4 pi. I take a fourth of that. I get my first tick mark is equal to pi. So it goes 1 pi, 2 pi, 3 pi, 4 pi. I could do it in reverse if I want. Okay, and that's what I have so far. My phase shift, I'm going to do -c times 1 over b, or positive pi over 2 times reciprocal of a half is 2. I get positive pi, and positive pi is right 1 square. So this first dot I have here is going to move over right 1. So the first dot is really here at x equals pi instead of the y-axis. And because it's a negative sine graph, the next dot will be minimum, middle, max, middle, and so on and so forth. I can just copy the pattern. Hopefully you know by now that the pattern always has every other dot on the midline. And I get this graph. that I have. Okay. So what do I need to know to write an equation? Well, I think I need to know what type of graph it is, whether it's a positive or a negative sine graph or a positive or negative cosine graph. I think I need to know the letters A, B, C, and D, but I'm going to only say A, B, and D because I'm going to avoid phase shifts. If I choose the right graph, I don't need to have to incorporate the phase shift in anything. So when I look at this first graph, I notice I have a max at 4, a min at 0. That means my midline is y equals 2 because I get 4 plus 0 over 2 is equal to 2. And this is my d value. And I get my amplitude is equal to 2. That's my a value. And I look at this, the first dot is at the minimum. So because of the first dot's at the minimum, this is a negative cosine graph. And then I have to figure out the period. So if I draw this one cycle of the graph, I notice it goes from here to here. I have my period is equal to 4 pi. And we had period was equal to 2 pi over b, but now I have b equals 2 pi over period. They can just switch spots, the p and the b. So my b value is equal to 2 pi over the period. So for this example, b is equal to 2 pi over 4 pi, or my b value is equal to a half. Well, I think I have all my information that I need. I have y equals negative 2 cosine a half x plus 2 is the equation for that graph. I'm going to do the same thing over here. I'm going to notice that my max is equal to 1, my min is equal to negative 2, and my midline, so 1 minus 2 over 2 is negative 1 over 2, so my midline is y equal negative 0.5. That's my d value. My amplitude is from here to here. My amplitude is equal to 1.5. When I do the difference between them, this is my a value. This one starts on the midline and goes up. So this is a sine graph. And now if I draw one cycle of this, starting here to here, I get my period is equal to 5. So my b value is 2 pi over 5, according to my formula we just did before. And I get y equals, well, amplitude is 1.5. It's a sine graph. The b value is 2 pi over 5. Don't forget your x. And the midline is minus 0.5. That is the equation of that graph. Well, let's put a nice bow on it. Let's do the Ferris wheel problem where we draw the graph of the Ferris wheel and then we figure out the equation for this Ferris wheel. So I know it's 20 meters in diameter. I mean, my radius is equal to 10. That's important. The platform is 2 meters above the ground. That means the minimum is 2. It's 1 full revolution every 8 minutes. That means my period is 8. And then it says when I'm at 0, that means I don't start my clock when I first get on. I wait until I'm at the 9 o'clock position. So the 9 o'clock position means you're at the midline and you're going down. Okay, I'm going to complete 2 revolutions and return to the boarding platform. So let's draw this graph. So since I know it's 1 revolution every 8 minutes, I'm going to go 1, 2, 3, 4, that's 8. 1, 2, 3, 4, that's 16. And I'll draw a couple more because I said I have to return to the boarding platform. I know the minimum is at 2, and the height is 20, so it's not 20 at the top, it's 22 because the whole distance between has to be 20. In the middle of these two numbers, let's see, my midline will be 2 plus 22, which is 24 over 2, which is 12. So the midline's at 12. I'll draw that across the page. And it says when I'm at the t equals 0, I'm at the 9 o'clock position, was in the midline, going down. So it's going to be middle min, middle max, back to the midline at 8, middle min, middle max, back at the midline at 16, and I have to get back down to the ground. So I'm right here, one more time, one more dot. I draw this graph. To the best of my ability, it looks like this. If I want to put some numbers on the x-axis, it looks like each one is worth 2. Looks like I'm at 18 when I get back to the ground. And let's see, my midline, I already said, was y is equal to 12. That's my d. My amplitude is from 12 to 22, so my amplitude is equal to 10. And that's my a value. And we said my period was the 4th tick mark, which is 8. And my amplitude is 10. And therefore, I look at this graph. This graph starts at the midline and goes down. So this is a negative sine graph. And my b value has to be 2 pi over the period of 8, which is pi over 4. My whole equation is y equals, it's negative. My amplitude is 10. Sine graph. Pi over 4 is my b value. X, don't forget your x, plus a midline of 12. And that is the equation of that Ferris wheel problem that we drew. Thank you.